Assalamualaikum and hello everyone. In this video, we will explore about system structure, which is how different components in computer system work together under the control of operating system. So, what is system structure? System structure is how computer components interconnected and work together to carry out tasks such as receiving input, processing data, and producing output. Computer system contains of four main components, which is hardware, software, users, and also data. These components basically work together to fulfill system main goal, which is compute. Next, we move to the I/O device. I/O device is input-output device to move data between computer and the outside world through I/O part. Each device has two parts, which is mechanical part like keyboard and also electronic part like controller chip. So in this slide, I will briefly explain about processor or CPU. CPU is the brain of the computer. It controls all the operation and processes data. It works with system clocks, performing data with each clock pulse. CPU consists of three main parts, which is control unit, arithmetic logic, and also the register. To read data from memory, CPU send address to the address bus and read signal via control bus. The memory then send data back on the data bus. The CPU follows a fetch, decode, and execute cycle. Well, that's mean fetches instructions from memory and then decodes it to simple actions, and lastly executes the actions.
What makes your computer run? What's the magic behind every click, every command, and every program execution? The answer lies in a tiny piece of hardware known as the computer processor, or the CPU, the central processing unit. This is the brain of the computer, the maestro that orchestrates the symphony of operations taking place within the system. Firstly, a computer processor houses the arithmetic and logic unit, or the ALU. This is where all the addition, subtraction, multiplication, division, and logical comparisons happen. It's like the mathematical genius in the processor family, tirelessly crunching numbers and making logical deductions. Next, there's the control unit. Think of it as the conductor of the orchestra, managing the execution of instructions and coordinating the flow of data within the processor and between other hardware components. It's the one ensuring that every piece of data arrives at the right place at the right time. Then we have the clock speed. This is measured in gigahertz, and it represents the number of cycles a processor can execute per second. It's like the processor's heartbeat. The faster the heartbeat, the faster the processing. Now, let's talk about cores. A processor can have multiple cores, each capable of handling its own set of tasks simultaneously. This means that a multi-core processor can juggle multiple tasks at once, enhancing multitasking and parallel processing capabilities. Moving on, there's the cache memory. The processor typically has various levels of cache memory to store frequently used data for quick access. It's like the processor's short-term memory, holding on to frequently used information for easy access. Finally, we have the instruction set. This is the set of instructions the processor can execute. It's often categorized as reduced instruction set computing or complex instruction set computing. It's like the processor's language, the commands it understands and can execute. Some common processor manufacturers that you might have heard of include Intel and AMD. Their processors are found in a variety of computing devices, from desktops and laptops to servers and mobile devices. To recap, a computer's processor, or CPU, is its brain. It's made up of several parts, including the ALU for arithmetic and logic, the control unit for managing execution, the clock speed indicating its pace, cores for multitasking, cache memory for quick data access, and an instruction set that it understands and executes. The performance of the processor significantly influences the overall speed and capability.
Next, interrupt occurs when the signal that stops the current task to handle something urgent. There are two types of interrupt, which is software interrupts for programs and also hardware interrupts for devices such as keyboard. Hardware interrupt also divided as two, which is maskable, which can be delayed, and also non-maskable, which must be handled immediately. So this is the end of my video. So system structure is a key to how your computer works. It ensures the component interact efficiently and also perform tasks seamlessly. Thank you.